record, but.
Are we allowed to record as well?
I'm recording it. I'll share with everybody at the end of this class.
Perfect. Okay, thank you.
Okay, so you know the traditional WAN, right? What are the benefits? What are the problems, etc. So I think that part. Guys, can you please mute yourself and put anything that you want to ask right now? You know, during the class, you can put in the chat window. And then at the end of the session, we will have a discussion on whatever questions you have, whether technology or anything else. We'll have it full discussion later then. Okay, so recording is going on. I've just started the class. Traditional WAN, you know the problems, right? You guys have attended some basic YouTube videos or some classes, so you know that I will not waste much of your time, but I'll just go through the slide. So there were a lot of issues, like everything was decentralized, configuration complexity was there. There were too many protocols, right? Get VPN, DM VPN, this VPN, that VPN. There was too many of the technologies, and that was making life of network security engineers really hell. So they have tried to compress everything, and we are going to, in further slides, you will see the ease and the beauty of the product. I will teach you from design perspective and the industry perspective. So you will have a lot of correlation. You will be able to correlate it to your work profile or the things that you have done as of now. Okay, because the design part is something I really love when I teach technology or when I learn technology. So the traditional WANs has these issues, and SD-WAN had these features: ease of config, templating for feature use. You can use a template again and again. Limited protocols, removed complexity, built-in redundancy, simplicity. These terms are not going to make much sense till the time you see some labs and practicals happening. So I'll just skip it and move into the traditional networking was about this, right? Management plane, control plane, and data plane. But here we have added one more plane. In fact, there's a couple of more people joining in. I'll just add them. Okay, so what happens in SD-WAN? There is a fourth plane called orchestration plane. Other than management plane, control plane, and data plane, I'm sure you guys know, you are all CCNA, CCNP certified, so you should be knowing what is a management plane, what is control plane, what is data plane, right? So I'll not waste your time on that. We will go into the core SD-WAN functions. So this is your SD-WAN where you have the communication is like that. So management plane is Vmanage, which essentially what it is going to do is all the configuration has to be done from Vmanage. So that's the reason it's basically the management plane. Any kind of device configuration, there is no other place from where you can do it. Either you can do it on the devices through CLI, or you can do it in a centralized manner through Vmanage. So, sorry. The next item that we have is control plane. Control plane is your vSmart controllers, because everything is controlled through vSmart controllers. Okay, so everything is gonna be controlled through vSmart controllers. You will not directly do anything. You will not directly talk to each other. Anything that has to be talked, anything that has to be discussed through vSmart controllers. We'll see that in a couple of more slides. These mystery words are going to open up, and you will have more clarity on this. Data plane is basically the same, the WAN connectivity and the IPsec tunnels, right? SD-WAN solution comprises of two items essentially, right? Which is a WAN connectivity, a safe WAN connectivity or secure WAN connectivity, and IPsec VPN tunnel over the connectivity. So what are the SD-WAN components? We got 4 components. We have a vManage, vBond, vSmart, and Vmanage. I'll just give you a brief of it because it's all going to come in detail in the couple of slides and when I get into MS Paint, etc. So Vmanage is a place where you go and do all kind of configuration. So that is the first install that we are going to do, is going to be the Vmanage itself. The second item that you have to install is generally is Vbond. And Vbond purpose is very specific purpose. It's basically to authenticate all the devices in the network. And it also has the certificate file or serial.txt file basically, or serial.viptela file that we have to download from Cisco website for licensing purpose. That basically resides as Vbond, and you have to authenticate everybody through that. So you need to have the serial number and the token number, which is generated by Cisco system, right? So that is the purpose of Vbond. The next item is vSmart, where we will create all the policies. If two devices want to talk to each other, they have to pass through vSmart. There is no direct communication from vEdge to vEdge. No vEdges can talk to each other till the time they pass through vSmart. Okay. So similar stuff you can see there. Vbond is everybody has to form Dtls tunnels with Vbond. Okay, everybody has to form a Dtls tunnel to Vbond, and once the authentication is done, then these devices can talk to each other. Guys, if I'm speaking a little loud or probably fast, you can just tell me so that I can slow down. If you're not able to understand something, you just tell me. I have this tendency of speaking faster sometime. So I'll try to reduce my pace so that you can understand each and every word that I say. Just type it in the chat window anytime you have any questions. So from here, the game starts. Okay. So what kind of in IPsec, or sorry, SD-WAN solution, these are a couple of items that you are going to see and you are going to play with. The first thing that you will see is what kind of tunnels are there in SD-WAN solution. Now, this is where I was talking about that you have ease of solution implementation. Plus, they have cut down a huge number of protocols. They have made the life very easy. So for underlay, they have Dtls, and for overlay, they have IPsec, Dtls and TLS, and for overlay, they have IPsec and GRE. Now the question comes, what is underlay and what is overlay? Okay, so I'm just going to use MS Paint to explain that. And sometime I also forget to switch the screen between different places. So when I say MS Paint, if you don't see MS Paint in a couple of minutes, you have to inform me so that I can start sharing MS Paint. Hope you guys can see MS Paint.
Yes, sir.
Okay. So we were talking about tunnels, right? We were talking about a thing called DTLS and TLS and IPsec and GRE. So two type of tunnels is what we are discussing here. So we are talking about DTLS and TLS, and we are talking about IPsec and GRE. So what essentially happens here in the SD-WAN solution, I'm just going to draw three branches. These are three branches, and I'm also going to draw a little internet diagram here for, okay, somebody's putting it something in the chat window. So these are, let's say, three SD-WAN routers, and I'm going to make it very easy. I have this thing of making diagrams very easy, simple ones. Now forget about any kind of complexity of where is Vbond, where is Vmanage, etc., etc. They are all in the background doing their job the controllers are doing their job. So ultimately it's the V edges which have to basically, once the controller configuration is done, it is these V edges which have to basically work. Okay. And that's where the IPsec tunnel happens and everything else happens. So the first thing that happens is, which is called underlay. The underlay process is that everybody needs to get authenticated to one of the controller called Vbond. Every single guy, including the Vmanage and vSmart. Vmanage and vSmart. Everybody has to get authenticated to vBond because he has the list of items that we have to download from Cisco licensing, etc. The first tunnel that you have when anybody wants to communicate to vBond, the protocol that is by default has to be used is Dtls. So by default, the protocol that's going to use is Dtls. What is the purpose of this? The purpose of that is to build something called an underlay, a secure communication, a secure network. Now you see that we are actually seeing something here which is not even visible. Let me type here internet and MPLS both. Internet and MPLS. So everybody has two connectivities. Now, if we look at from the logical perspective, the topology is going to look like this, right? This is logical topology. But the physical topology could be anything, right? It could be hub and spoke, it could be full mesh, it could be partial mesh, it could be point to point. But from here, we can't make out because that is a configuration part, right? You can do any kind of configuration. So here, what it looks like right now, sorry, from physical perspective is that these are three branches talking. But logically, there are, so this is a physical one, and then you have logical. What are the logical topologies here? We are going to get into the detail of that also, hub and spoke, or I'll share it in the slide there. So these three devices, if they want to communicate to each other, what is the process they have to follow? The first process they have to follow is they have to get themselves authenticated with vBond. If you are a vEdge, a virtual device, you will have the file that you downloaded from Cisco and some certificate, some built-in mechanism that Cisco has for their devices. But if you have a physical device, a vEdge physical one, or a CSR router or ASR series routers, they are going to have some TPM chips inside them, which will have the authentication mechanism, or which will have basically a chip which will authenticate that this particular device is licensed and it is from Cisco and it's original, etc. So no matter what is the mechanism, whether you are using, because we are going to use vEdges as a software, but vEdges are also available as hardware devices. These are old Viptela switches. Okay. Also remember that vEdges are going out of context soon because Cisco is now making most of these products in the coming time as end of sale or end of future, and they are going to promote Cisco platform, which is cEdge or Cisco whatever CSR routers or ASR routers. They are all going to run the software cEdge, which is iOS XE, right? Which is we are very comfortable with that. It's a iOS kind of CLI. Almost everything is like iOS kind of thing, and Cisco engineers are very comfortable with that. So that is what is the future plan of Cisco. So vEdges are getting obsolete, not right now, probably in 1 or 2 years. That's a plan basically they have. A couple of models are obsolete as of now, but what I have heard from the industry expert is that ultimately Cisco is going to have these products only for all kind of implementation. So we were talking about that each of these devices, whether it's vManage, vSmart, they have to go to vBond and they have to get authenticated. Now, as soon as these devices are authenticated, the vEdges do not need to have a permanent tunnel to vBond. There's no requirement. This tunnel will be basically broken, but vBond will have permanent DTLS tunnel all the time with vManage and vSmart. So vEdges, once they get authenticated, they do not have a permanent tunnel with the vEdge devices or with the vBond device. Cool. Now, so that's where the DTLS comes in. DTLS is optional for most of the device communication except the vManage and vBond or vSmart communication. It has to be DTLS, right? Anybody want to talk to vBond, basically They need to have DTLS connection to them. And if you want to have vEdge to vEdge and other mechanisms, you can also configure TLS, but nobody in the industry uses TLS as such. So this protocol, what DTLS does is a lot of things. One is it gives you secure underlay. Again, the word is underlay. Okay, so let me write if I'm not written anywhere. The word is underlay because this is the base over that IPsec is going to run its VPN tunnels. Okay, which is the second type of tunnel. This is called overlay. So this becomes overlay. Overlay runs on what? Underlay. So underlay is to secure the basic communication between all these components. The basic communication between all these components. Okay. And overlay is once this basic communication is secure, all the devices are authenticated, then we have to decide which device can talk to which device. By default, this is all security segment. So if you have a VPN here on R2, a private subnet, which needs to talk to R3's private subnet, right? You have to decide, you have to create a policy for it, and then only from R2, the communication is going to happen to R3. Now, how that communication is going to happen? That will happen using overlay. Overlay is policy based. Overlay is policy based. You decide a policy. Nobody can talk to nobody at the start, but once you create certain type of policies, there is basic communication allowed for IPsec tunnel also, which we will discuss later. But for the timing, assume that nobody is allowed to talk to nobody. Okay. So I hope the underlay and overlay is clear. Underlay is basically these protocols, which are basically for the secure communication of all these devices to vBond and to each other. These devices need to get authenticated only to vBond once, but they will always maintain a full connection to vSmart, Vmanage, and vSmart. So vEdges, right, in a nutshell, vEdges will have a permanent DTLS connection, all the time to Vmanage and vSmart, but they will have a temporary connection to vBond on need per basis. First time is mandatory because you have to get authenticated, and after that the tunnels are torn down. Okay, there's a couple of more people joining, waiting in the waiting room, so sorry for that. So this is the concept of underlay and overlay. I hope you guys are clear. Wherever when we talk about underlay and overlay, this is where the concept is. Underlay is always the base stuff, right? Under the hood kind of stuff. And overlay is going to be on this particular physical network. Once it is secure, you should be able to create more policies. Now you see that for your VPN, you have IPsec and GRE2 protocols. GRE is as good as IPsec, right? Because you have already secured it with the DTLS, which is very secure for your base, for your communication, right? So there is no chance of you getting hacked or something else. So IPsec and GRE, two options. There are no other protocols in the scene here in terms of anything else. They have their internal protocols, which we are going to see through slides after this. Okay, a couple of more people joining. Okay, so are we clear about underlay and overlay? I think everybody is clear about it. You can write in chat window if you have any question or any doubt. I'll try to answer that. So this is one concept. Let's go back to the slides again. DTLS and TLS are basically different protocols. These are two different protocols. I think DTLS is more secure. TLS is a little less secure, but I'll find out more about it. DTLS and TLS are for the underlay, absolutely right. So DTLS and TLS are for underlay, and the IPsec and GRE are two protocols for overlay. Yes, DTLS TLS is going to be used later for your IPsec phase 1. Okay, because the communication is already secure, so it doesn't use IPsec phase 1. It directly moves to IPsec phase 2 because the phase 1 is already secure. Okay, so back to the PPT. Yes, guys, I'll explain the difference about all these devices. And when you do the configuration tomorrow, you will be able to see what is the difference basically. Overlay the logical topology, actually everything is logical and physical together, right? But overlay seems more like a logical topology, and underlay is more like a physical topology. That will be correct. So 4 types of VPN, guys, here: hub and spoke, full mesh, partial mesh, and P2P. You can create these policies by default. What is the IPsec policy? Full mesh. By default, if you do not define any policy, it's going to be full mesh, but still nobody will be able to communicate to nobody except certain conditions. So once we reach there, we'll discuss that. So what is the VPN here? Some definition of VPN changes for sure here. Now, VPNs are not the VPN that we used to see and we used to know at one time. These are essentially VRF. These are purely VRF, okay? They act like VRF, they don't act like a VPN. So each VPN is basically, under the hood, is a VRF. The numbers which are basically there is 0 to 65,530. 0 is reserved for WAN interfaces for the transport, and 512 is reserved for the management interface. Rest of them are all configurable as per your wish. 0 is also known as transport, and 512 is basically for management purpose, right? And then you can configure these rest of it. I'm just going to explain you VPN a little bit more with the diagram. I'll go back to Paint again so that I can just okay. So let's say you have this device, one of the edge device, and then you have, let's put it like again 3 devices here. And this is your one of the interface, which is private interface, and this is your public interface. Or if you have 2 interfaces connecting to again MPLS and internet, then you have 2 different interfaces. So you have 2 WAN interfaces and 1 LAN interface. Okay, everybody is connected to MPLS and internet. So you have 2 interfaces essentially. One is MPLS and 2 interfaces. One is connected to MPLS, the other is connected to internet on each device, each of the vEdge router. Now, so this interface can be anything between leaving 0 and 512. It could be anything else. So these 2 interfaces are fixed. You can't use them. But for this private interface, you can use any other interface name or whatever service VPN number you want to use. The thing is, from here, 65,530. Any number that you want to use is absolutely configurable for your private interfaces, and basically you can have a communication. Now I'll come to the point of why this doesn't act like a VPN that we have seen. interfaces that we have seen, why does it sound like a VRF? Okay, so the reason for that is, so how the configuration happens in the devices is, it's something like this: interface VPN 0 and interface, and you configure your interfaces. So we discussed what is VPN 0, right? VPN 0 is dedicated for WAN. You can have up to 7 WAN interfaces per device on vEdges. As of now, Cisco allows you to have 7 WAN interfaces per vEdge or per device. Okay, so you basically have whatever number of interfaces you have, whether you, let's say I'll give it an interface name also. So 00, gigabit 00, and gigabit 01. So what is it going to be? Which VPN? VPN 0, always VPN 0. Why? Because VPN 0 is transport. You can also call it, that's the reason I said WAN. It's called transport VPN. Sorry, transport VPN. Okay, it's always going to be transport VPN, which is basically means it's going to be WAN interface. These are going to be WAN interfaces. And 512 is going to be your for management purpose, for telnetting SSH or something else. For all the management purpose, you are going to use 512, which is fixed. You can't use it for any service VPN or anything else. Then you have service VPNs or VPN that we basically talk about. These service VPNs is these numbers, right? These are the numbers that we discuss. And basically what happens on this particular thing is, you go to that, and let's say I choose to create VPN 10 and interface, whatever interface I want to assign. What is the interface? This one, let's say it's gigabit 04. So we'll go here and we'll say 04 IP address, right? Whatever IP address, and protocol is going to be GRE or IPsec. You have a choice here. It's as simple as that. Just this much of kind of configuration for configuring your VPN interface. Now we are actually, again, the thing about VRF is still not clear, right? Why I'm still saying it's a VRF. So what happens is, let's say if this is VPN 10, okay, and you also created a VPN 10 here, and this VPN 10, let's say here you have a subnet, this particular subnet is 10.1.1.0/24. And here again, if you create on this particular device a VPN 10 IP address, interface, etc., all again, and IP address, maybe the subnet that you are giving here is 192.168.34.0/24. Okay, so what happens by default is, what happens in VRF? What if these two guys are in the same VRF? Will they be allowed to communicate? Yes, right? That's the reason I said that it's a VRF, right? So because they are part of the same VPN number, which is under the hood is a VRF, they will be allowed to talk by default without any policy, without any configuration. Except this scenario, nobody is allowed to talk to anybody. You have to create a specific policy for VPN. But in this particular scenario, because you have the same VRF number or same service VPN number, right? So from here, we are not going to use word VRF here. We will always call it service VPN. Okay, so once you have the same service VPNs, you will be able to communicate to each other. If you do not have, then you can't communicate. You need to create a policy and then you can communicate. But where will you create a policy? Can you create local policies for this? No. The policies are always, nobody can create policy or can apply policy except whom? Except vSmart. When you want to create a policy, you create it on Vmanage, right? But it has to be executed at vSmart. You write the policy. Vmanage is a place where you write things, but different items get executed at different place. So if you want any other kind of communication, now what happens for this? If the VRFs are matching, you do not require Vmanage intervention or the other fellow's intervention. That's right. All policies are basically needs to be configured at vSmart. So are we clear about why did I say it VRF? Any point on this particular slide or this design, you can ask me.
Sir, just a question, like the gig ports 0/0 and 0/1. So both of them are the WAN interfaces. So they are said to be VPN 0, sir? Both the
Absolutely.
interfaces?
Absolutely. Up to 7 interfaces can be part of VPN 0. Yeah.
Right. So one question there. So when you said that the VPN 10 service VPN resides on, I mean, can you just go back to that diagram, please?
Yeah, I'll do that. Okay.
So so on 0/4, that is your 10/10.1 subnet, and your R3 router, you have the VPN 10 again, which is 192 series subnet, right? If you have to establish, although they are part of the same VPN, policies are written somewhere in the vSmart, correct?
Mm-hmm.
So your communication between R2 and R3 is established through the vSmart, which means it has to use one of those transport gateways to go to vSmart and then come back, or how is that communication being achieved?
No, the policies are basically are created at vSmart, but once the policies are pushed, they can directly talk to each other.
Okay, so there is no transport required, like an MPLS internet to go to the vSmart. So basically, it's going to be data communication directly. Is that what you're saying me?
That's right. So there is no communication that is basically going to pass through in terms of data plane. It's just control plane intervention, not the data plane intervention. The control plane intervention says, let's say your manager says, you two guys cannot talk in the office. Okay. So it's the communication is as simple as that. The manager says that you both can't talk or you can talk, right? But talking is going to happen between you and this fellow. But who will decide? The manager decides. I know it's a bad example, but that's the only thing that came to my mind. The managers are very rude here, right?
Yeah, so basically what I'm trying to understand is how does the communication occur? So is there a DTLS, TLS phase 1 connectivity and the IPsec connectivity between R2 and R3, correct?
Yeah, so
How do you do it?
yeah, I'll just go back to that place. So let me clarify that situation again. R1, R2, R3, all the devices need to have all the time a connection, DTLS connection with Vmanage and vSmart. All the time. But vBond only once. Now, why is it all the time it is required? Because Vmanage is going to configure and push something, right? Is going to configure and push something through vSmart to these people. But once that is pushed, right? Once that is pushed, if vSmart says R2's this VPN can talk to this guy, right? They will directly talk to each other. I mean, directly means whatever is their policy. Is it a point-to-point policy? Is it a hub and spoke policy? Is it some other policy? But by default, I told you, full mesh policy is applicable. By default, it's a full mesh policy. Got it?
Yeah, so
Or
what kind
anything
of
left?
so the data plane connectivity is through IPsec, is that what you're saying me?
Data plane, yeah, that's absolutely is the point. The overlay, the data plane is overlay. Is going to be IPsec or GRE, and underlay, which is, sorry, data plane, and the control plane is going to be through DTLS. DTLS is basically for establishing that later the policy push-up happens through which protocol? OMP. OMP is the protocol which will be used for all kind of routing and policy push-up, etc., etc.
Okay.
Okay, couple of chats here. Yeah, so basically DTLS is, Farhan, DTLS is always between all the V edges and vSmart and Vmanage permanent tunnels. It will be permanent tunnel, will be never broken. And on the top of it, there will be IPsec tunnel between devices, depending on the logical topology. Hub and spoke, partial mesh, full mesh, or anything else.
And in case, if you're pushing the policy from vSmart onto the V edges, would we have a DTLS there as well, or is not required?
Sorry, pushing the policy from where to where?
From vSmart onto the V edges, you can only push the policies from vSmart onto the V edges, right?
That's correct. Yes.
So when you're pushing the policies, do you have a tunnel there, or how does that happen? It's just like a normal data connection.
No, always. DTLS tunnels are never broken. See, I don't need VBond because I have one-time authentication with VBond. No device needs to communicate except Vmanage and vSmart have all the time connection to VBond. But no vEdge needs to talk to VBond, so the tunnel is disconnected. But we need to have a communication. All the vEdges need to have a communication all the time with vSmart and Vmanage. So permanent DTLS tunnels.
Oh, thanks.
Okay,
So
so
whatever the communication between the V edges to vSmart and Vmanage via the DTLS tunnel.
yeah, so DTLS is, take it like, you have a HTTPS website opening with google.com, right? You say gmail.com, you have an HTTPS connection with them. Further, whatever you do, whether you do video conferencing or audio conferencing on Google websites, it's all secure using the SSL. So SSL is your first communication to you and Google. Once your connection is secure, no man in the middle, nobody injecting something else, because the communication between you and Google is secure. Now you do Google Meet, now you do Gmail, now you do Google something else, and basically all those activities are overlay. SSL is underlay.
Okay.
Yeah. Vijay, I have one question. It seems like even though you create a policies in Vmanage, it is vSmart that pushes the policies to the V edges. Is that correct?
That's absolutely correct. Yes.
So, which means that the V edges, it makes sense for V edges to always have the DTLS tunnel with vSmart. So, but why do they need a permanent tunnel with Vmanage as well, since it's vSmart that pushes the policies out to the edges?
Yeah, so some of the policies, there are two kind of policies. A policy which will be basically control plane related and centralized policies, which will impact two people talking to each other. And there are local policies, which means you want to block something on the local interface of a device, which is a local policy. For local policies, Vmanage doesn't need to consult vSmart. Vmanage can push those policies there, which is some interface configuration, or maybe the template configuration, or some feature configuration which is beyond the data plane decisions, which is taken by the vSmart.
Okay, thank you.
Okay, so here is VPN, right? So you can see the topologies, different type of topologies, only 4 type of topologies possible.
We are still seeing a paint screen.
Oh, sorry. Yeah, that's what is. Okay, so you can see these are the topologies actually, and we are going to talk about these advanced features also, that what is more you can do. Can you put a firewall in between? Can you put an intrusion prevention system in between IPS and everything else? Those are going to be in the advanced topics when we discuss all these things. So traffic forwarding on the LAN. What kind of traffic forwarding policies can you basically implement? There are 4 type of policies which are basically there. And I said last time also, maximum 7 gateways are supported per site. Okay. I think it was, sorry, 16 interfaces and 7 gateways. That was the thing, right? 16 interfaces per device and 7 total gateways for application. So I think I was mistaken there. 7 gateways for these features and 16 interfaces maximum per device. Okay, for WAN VPN 0, 16 interfaces, not 5 here. Okay, so these are basically the traffic forwarding on the LAN. When you go to your edge devices, again, I will explain this with a diagram. Sorry. So I'll pick up another diagram and I'll go back to share thing here so that I can explain it well. Actually, I'm using a 2-monitor setup, so I get confused sometime. You are able to see the paintbrush?
Yes, Vikas.
Okay, excellent. So let me put it like a switch here. These are 3 switches in my network. How many are supported simultaneously? We said 7 gateways. Each gateway having 16 interfaces, right? 16 WAN interfaces and 7 gateways in total supported. Now these gateways, let's say I have a host here, host A. So what are the mechanisms which are basically supported for load balancing this traffic over when it passes through or when it has to go to the WAN, right? So the first thing that's going to happen is active load balancing. This is very simple, right? You can understand it. Active, like you have seen in other protocols also. Then you have active, but weighted one. Active, where you can define the weight. One gateway has more weight. Remember those HSRP and VRRP configuration, you can define weight over the interfaces, which interface is going to have how much weight, etc. Okay, so here you can define what is the kind of weight you have. Here then you have active pinning. Anybody has a background in UCS? Anybody remembers MAC pinning from UCS?
No. Can you just explain that part? Active pinning?
Yeah.
Thank you.
Again, my mouse got stuck. So what happens is that you can actually pin certain applications to certain gateway and certain interface. You say that all my Azure traffic is going to pass through this particular gateway and this particular interface. So you are pinning this particular gateway, this guy, to this particular interface so that you do not have any kind of discontinuation of communication. A lot of time what happens is the checksum, and there are very sensitive applications. If some traffic is passing on this, some traffic is passing on this because of different security mechanisms and all that, the application at the end will not work, or they will not accept a connection from you. So the requirement is that generally about voice or IP applications, right? With the H323 and SIP gateways and all that, they have requirement that certain traffic has to come from certain port itself. You cannot change the port and you can't do a lot of other activities. So you are pinning it to certain gateway, and further you can pin it to certain interface on that particular gateway. Active pinning. The next one that you have here is application aware SLA. You can define SLAs. Predefined SLAs are also there, but you can define SLAs by creating control plane policies on vSmart, and you can apply this particular application will only go through this particular gateway. If that gateway fails, then the other policies can basically take over. Cool. So any question about these 4 items?
Because when you say gateway, did you mean it was the WAN transport?
Yes, yes, absolutely.
Basically, we are talking about 7 WAN transports here, correct?
Yes, 7 maximum WAN routers, physical devices.
Okay.
The maximum supported at this time at one site. Remember that, at single site. Right? So single site, 7 gateways are supported at one time.
You said like we can have 16 WAN interfaces per edge, right?
That's right, yeah.
I mean, earlier it was said like we can have, I mean, under the transport VPN, only 7 interfaces max can be
No,
configured.
that's what I said, that that was mistake. 7 are gateways and 16 are interfaces.
Okay.
I'll recheck it again. You know, the facts can go wrong.
I'm a little confused with the correlation that you're doing. So when you say 7 gateways, so when if there is one ISP router, so that's, I mean, like a WAN edge router, a V edge router, right? Which is at the customer side. It can have 7 different gateways, meaning 7 different transport connections. It could be MPLS, it could be internet. It
No,
could be
no, no, no,
internet
that's
type,
wrong.
right?
That's wrong. I am saying 7 physical interfaces, each having 16 interfaces. So 16 into 7 total WAN connections. 7 physical devices, 7 gateways, 7 physical devices with each 16 interfaces.
Oh, okay. 16 WAN connections, you mean?
That's
okay.
correct. That's correct. Yes.
Okay. Thank you.
And each gateway can also be known as vEdge, correct?
No, the gateways could be vEdge, could be cEdge, could be physical devices, ISR series. So it could be basically any of those.
Okay.
vEdge is just one of the items, right? The cEdge is there. The ISR series are there. Now they're adding a lot of new products also into this series.
Got it.
Here also, I would like to add a point, as I'm already here, that at each site, okay, let me go back here to explain a site. So this is a site where you can have, we talked about a couple of gateways, 7 gateways maximum possible, right? So here I have 5 gateways. So this is one site. In this, you have a lot of switches here, and your private whatever networks and host and everything else is basically there. But you have maximum 7 gateways. This is a single site. Now, as of now, the problem here with these devices is that either you need to have these gateways as single kind of a make. So if you have vEdge here, you need to have all 7 as vEdges. If you have cEdges at some site, you cannot mix couple of vEdge and couple of cEdge here. That is not possible. You can't have vEdge and cEdges on a single site. Okay, the reason for that is the protocol they have, the vEdges, because Cisco acquired this company from Viptela, and these guys have a very limited implementation of VRRP and other protocols. And Cisco cEdges are iOS devices, right, with XC core. They have a different Cisco proprietary as well, or they have a full implementation of VRRP. So a lot of protocols will not match. Also, cEdges also support BGP, OSPF, and EIGRP, while the vEdges only support BGP and OSPF. So a lot of differences, huge number of differences between these devices. So when you are in a design phase, make sure that you know that only similar type of devices should be there.
Can cEdges can be mixed with ISR or ESR routers?
I think you can do that.
Because they're also Cisco products, so it can happen.
Yes, but Cisco recommendation as of now is that you should have similar type of product if you are going to implement traffic forwarding using these different algorithms and everything else, because some of the product may or may not support these load balancing mechanisms. Cool. Now we are going to get into a very complicated topic, which 90% of the people are always confused about, no matter how many times you explain to them. Okay, so I will give it a try, and if somebody else has a good knowledge about it, kindly correct me wherever I go wrong on this. So TLOCs, guys, TLOC is basically the next hop for the communication. And there are certain things which are different in this particular TLOC as compared to a plain and simple next hop. Okay, so it's a three tuple system. Tuple is nothing but a list, right? But a organized list where you cannot change the values up and down. So basically it has to be a systematic list, right? So that's what is called tuple. That means system IP comes first, coloring comes later, encapsulation comes after that. Right? It's a simple list. If you have done Python programming, you know what is tuple. So system IP, right? I'm not talking about interface IP at this time. We are talking about system IP, right? Given to the whole system, not to the interface, given to the whole device, right? Anybody has done any kind of VPN, guys, before based on the loopback to site VPNs or any other kind of VPNs with loopback on a public network or public internet?
Yes.
Okay, cool. So I'll explain that scenario. Why do we do that and what is the significance of that? So I have two connections, two ISPs, two different ISP connections. And traditionally with my IPsec VPN, I want to have a VPN tunnel to these two sites between A and B, right? So traditionally what happens is either you create two VPN tunnels.
We're not seeing your diagram.
Sorry.
Are you sharing Paint or
Yeah, I'm
something?
sharing
Because
the
I don't
MS
see.
Paint. Yeah, I'll just share it. Okay, so I have two sites here, site A and site B, and site A and B. Generally, what used to happen is they used to use a loopback interface and have a tunnel to the loopback interface so that when the VPN tunnel physical interface goes down, right, you still will be able to communicate to each other. In that case, you have to map your physical interfaces to loopback interface, right? Because loopback never goes down. So even if your physical interface goes down, right, the loopback never goes down. And using different mechanism, we'll find out why the tunnel is down, and then basically we can either restore it. Even if we are not restoring it, that's absolutely fine, because you have a tunnel with the loopback. Your application disconnection never happens, because your tunnel is through loopback to loopback, not physical to physical. In TLOC, what happens is you have similar stuff. So I'm going to pick up another diagram here with three sites again. And we are again going to have an internet, a bad internet, and a bad MPLS design. I was very poor in the designing actually in my college also. And I'm continuing the tradition. So here I have MPLS and internet lease line, or 4G connection, whatever way we want to call it. So here we have A, we have site B. Take it like site rather than individual devices, or take it like individual device for the timing to understand this scenario. So what happens is that the most of the tunnels, or all the tunnels that you're going to have are going to have between, let's say, this particular device, his physical interface is going to be 12.12.12.12. Okay. His physical interface is going to be 13.13.13.13, and similarly, this is going to be 14.14. These are physical interfaces. Remember that these are physical. Now we have loopback or system IPs. System IPs are any loopback type of interface or any interface, basically, you can say that. So my tunnels are going to form between T-lock to T-lock. T-lock to T-lock. Right? System IP to system IP. My communication is happening using, so that is your T-lock. So you can, or let's call it T-lock neighborship rather than tunnels. Let's call it T-lock neighborship. My T-lock neighborship will happen between system IP to system IP, but without physical IP, right? Without a transport or routing being fine, I won't be able to reach from 111 to, 222 to 111. I need to have a good mechanism or communication between these two devices. Right? So let's say everything is fine, routing is fine, you are able to reach there, and you know that his system IP, so you have a T-lock. Now, so what is the T-lock? First item in T-lock? System IP, not physical IP. Second is color. Color has two items, string and WAN interface. And then you have encap, which is two kind of encap, GRE or IPsec. There are a lot of other items also. We are going to discuss in next couple of slides that thing. So the system IP color, and in the color, basically what is a color? Color is a string, just a differentiator. That this connection is connected to MPLS, so color is MPLS, and this is connecting to internet, so color is internet. You can also create your own color. You can really create a literal color called blue and red, etc., etc. That's absolutely fine. There are predefined strings there, public internet, MPLS, private interface, private this. There are a lot of pre-created. Cisco SD-WAN solution gives you all that ready-made also. And a WAN interface plus the encapsulation. Okay, so that is your T-lock.
Sorry, so when you say WAN interface here, would it be the gateway?
Sorry, WAN is what?
Is it the gateway?
No, the gateway is interface. Interface,
Gateway
WAN
interface.
interface.
The physical interface.
Yeah. So interface coloring is very important, guys, because otherwise I will not come to know the packet has come through MPLS or has come through internet to SD-WAN. SD-WAN will not have that idea. Here, site A wants to know that some packet has come from site B. They need to have an idea, did it come through MPLS or did it come through internet? A differentiator. Okay. Also, I want to explain it a little more in detail, although I was planning to do it when I have a detailed T-lock session and detailed OMP session, because both are connected. But I'll just explain a couple of things here. So the number of T-lock neighborship that you have, okay, the number of T-lock neighborship that you have will be, this B is by default going to neighbor to this interface, to this guy, to this guy, and to this guy, essentially. So total 6 tunnels here, 3 devices, 6 tunnels each, 6 each, 6 each. Okay, which is a very bad idea. Also, a lot of time what happens is that you may not have, okay, connectivity over MPLS in certain circumstances, because these are both private interfaces. So if you try to do, let's say I have a site private interface here called 5.5.5.5. This is my service VPN, okay? Service VPN, which means my VPN. And here I have 6.6.6.6, my service VPN again, and they want to communicate to each other. Okay, will they be able to communicate over MPLS? MPLS, remember that is a private interface to private interface. Right? A private interface to private interface. So to reach to them, I may or may not have connectivity depending on how have we configured things. So what was the problem here? The problem is by default, TLOC forms full mesh. TLOC neighborship is full mesh, which is a very bad idea if you have a couple of thousand sites. If you have 1,000 sites, guys, how much is going to be? A full
Yeah, that's
mesh?
formula used like n times n minus 1 over 2, right?
That's right. That's absolutely correct. 1,000 into 1,000 minus 2, right? So, and look at it, the problem is that the chaos it's going to create, right? So they have an option in during the configuration when we go to the Vmanage, there is an option on the interface to have an option of restrict, which is by default not enabled. You can choose restrict option, restrict on the WAN interface. So what is the meaning of the restrict here is that all the people who are communicating to each other, let's say if I have internet, everybody is using internet, then those people are going to form neighborship over that internet, and anybody who's using MPLS, only those people will form connection over MPLS. Internet guys will not try to form TLOC neighborship to MPLS interfaces. MPLS interfaces will not try to form with the internet because they can't do that. MPLS is mostly private interfaces. If you want also, you can't form a neighborship with this because MPLS is generally the service provider gives you these two connections and they say you pass the data through me, whatever is your private thing that you want to do is absolutely fine. I'll give you private interfaces most of the time. So private interfaces can't form, but they will keep on trying the TLOC. That's the reason the restrict option came, that internet guys should form neighborship of TLOC neighborship over internet. What if you have created something called a customized color called blue rather than internet or public internet, you created blue. Only people who are using blue will be able to communicate to each other. Guys, any doubt, any question here?
So basically, it's like a VRF again, right? Like the color is like a.
Not like that, but the tag will be the right word, you know. Like in QoS,
Yeah,
you
okay,
use
tag.
tagging.
Right.
Yes.
So what it essentially means is service VPNs which are behind sites. For example, if there's a service VPN of 6.6.6 behind B and if there's a service VPN of 5.5.5 behind A, and if there is a TLOC of private which is goes down, it cannot use the TLOC of internet to reach that, correct?
Most of the time, yes, MPLS connections are private, but if there is a reachability, they will probably be able to use it if restrict option is not used.
Oh, if restrict option is not used, okay, then they can use both of these transports, correct?
That's right, and that's the reason restrict option is not by default enabled. So by default is a full mesh of TLOC.
But for that communication, you said that there has to be a system IP communication between 2.2.2 and 1.1.1, correct?
See, system IP communication is only going to happen when the physical interface of physical transport is available. If one side you have MPLS private interface, right, and the other side you have internet, you probably will not be able to reach there.
Okay. I'm trying to understand where will the system IP come into place when we have that kind of connectivity, right? So if you have to connect two different
Yeah,
sites.
so system IP, I'll tell you, system IP, the purpose of system IP was so that if any physical interface goes down, if you have 2 internet connection or 3 internet connection or 4 internet connections, you should be able to communicate to them. let's say if you have third internet, right? Your MPLS goes down, your internet, this goes down. So because you have a tunnel to system IP, not physical interface, your tunnel will still pass through.
Okay, and this system IP is advertised in the in your whatever OMP or whatever you're using, correct? Or
TLOC, yes.
so system IP is advertised in the BGP or the IPsec connectivity.
No, they have nothing to do with all this, right? IPsec guys have nothing to do with all this. This is control plane communication. Once a control plane is set, IPsec GR is data plane. They are not even bothered about, they just need to be told by control plane that these are the subnet available, you can reach it, and the protocol you use is GRE over IPsec. Your keys are created, and that's how the communication will happen. Data plane has nothing to do with control plane, except the control plane dictates how data will flow.
Oh, okay. And system IP comes into picture only during the initial phase, correct? During the building.
No. System IP is always there. You have always permanent VPN tunnel through system IP to each other.
Okay.
TLOC, see, TLOC tunnels, we generally call it TLOC neighborship, right? But TLOC neighborship is system IP to system IP. But under TLOC, right? Under TLOC, you have IPsec tunnels also. Because they need to know the physical stuff. So we'll discuss next item here, but let me look at the chat. It acts like a router ID will be best, word to define it. Absolutely, yes. In OSPF, you have router ID to router ID communication. One of the interface goes down, still you have OSPF communication through the other interface. So router ID is the best keyword. Absolutely right.
Got it. Okay, yeah.
So OMP, okay. OMP is a control plane protocol, and the whole communication happens through OMP. Okay, it's a BGP-like protocol, which basically means that it has the capability. Very few protocols have the capability to carry attribute.
We can only see your paint screen.
Sorry, just okay. So BGP-like protocol, where you can carry attributes, and that's the reason we call it BGP-like protocol, and you can distribute routes to all the sites. You need a protocol to distribute the service VPNs, right? The private subnets. Because IPsec is just encrypting, decrypting. Who will provide the communication? Who's going to provide the protocol for communication? In DMVPN, which protocol do we use generally for supplying the routing?
EIGRP or OSPF, right?
Correct. In GRE or IPsec also, you require some protocol, whether it's EIGRP or OSPF or any other protocol. You need some IGP so that you can provide route from one site to another site. So we have to use a specific protocol for that communication. Here, that thing is taken care by OMP, so you do not need to run between these devices for their one TLOC to another TLOC routing, one site to another site routing, IPsec to IPsec communication of the subnet distribution. You do not require a third-party protocol, you require OMP. It can distribute routes to all the sites. Routes can be distributed, but will they communicate to each other or not is decided by control plane. What type of routes are basically, it can distribute in OMP, redistribute connected, static, OSPF, BGP, and C-edge devices can also do EIGRP. V-edge cannot do that. Okay, so if you have service VPN, for this also I have to go to MS Paint. Okay, so let me go first to MS Paint. So you have site A and site B. I'm just going to pick up two sites, the internet, and they want to communicate to each other. So there is a private subnet service VPN here and service VPN here. How will they communicate? How Are you configuring some kind of static route that for this particular subnet you have to go through this system IP and through this guy only you will be able to reach? Are you putting some kind of routes like that? No, we generally don't do that. We just put a default gateway, right? And if you have another service VPN, another service VPN, another service VPN, hundreds of service VPNs at different sites, maybe thousands of vEdges in the large scale enterprise companies, are you going to do static routes? Right? Nobody likes to do that. So what do? These service VPN, as soon as, remember that what I'm saying, when you go to the gateway and you say interface VPN 23 or 123 or whatever it is, right? IP address and whatever. As soon as you do that and complete it, what will happen? This route, because it is connected route, by default, connected routes are redistributed into OMP. OMP protocol will redistribute this without you doing anything else to this particular site and all the sites who should receive this particular service VPN. As soon as you create it, who takes care of that? The OMP takes care of that. That is the responsibility of OMP protocol. Cool. So that is the responsibility of. Now some protocols are redistributed by default. OSPF, BGP, you have external routes. OSPF and BGP internal routes are redistributed by default in OMP, but OSPF and BGP external routes you need to redistribute manually.
OMP is a protocol that is already enabled in a VH.
By default, yes. All these protocols are by default enabled. The Dtls, the IPsec, VPN, GRE, everything is by default. You do not have to configure any of these protocols. They are pre-configured. You have to just tell which is the VPN interface, VPN 0, interface VPN 23, and it is going to take care of looking at what VPN number it belongs to. All these protocols are by default enabled, but you can disable OMP and you can do some changes also into that. That will create havocs, right? So OMP attributes, what are the attributes OMP carries? We discussed in the previous slide, right? The OMP has attribute, it can carry attributes. So here is the point is, what are those attributes? So here OMP has route type, origin, origin IP, site ID, VPN, preference, tag, service, and port. Route type, right? We discussed route type. It could be internal, it could be external. Then origin, who is the, what is the origin? Is it OSPF, EIGRP, OSPF internal route or external route? You know, which router originated it? So origin IP, which site originated it? Site ID. Is this particular subnet is coming from a service VPN? So VPN number. Do you want to give any kind of preference to this particular route? Yes, you can give preference. Do you want to apply certain type of policies using tag? Yes, you can do that. You can tag it and filter it later, like you do the tagging in OSPF, BGP, EIGRP, and all these protocols, right? Similar stuff. Is it carrying any kind of service chains, right? So is it carrying any kind of service like firewall, intrusion prevention system, etc.? And the port number. It's basically the port number, sorry, the last item. Guys, any question, any doubt here on this?
Hello, sir.
Yes.
So can you explain the OMP means where OMP used between vEdges or
OMP is essentially between vSmart and vEdges. vSmart and vEdges. Guys, can you please mute yourself? Okay, I had to mute everybody, guys. Anybody wants to speak or, first try chat, putting in the chat window. Okay, can you write in the chat window any kind of question that you have? Anybody want to basically speak up? They have to, I think, raise a hand, or I have to find them and unmute because there was a lot of unnecessary voice coming from there. So OMP protocol is essentially between V edges. So let me go back to Paint again to explain a little bit more of this thing, so that first I have to go back to this, share Paint again. So you have these devices, device 1, device 2, device 3. If they want to communicate anything to each other, right? Everything, all instructions are going to be from whom, will come from whom? It's going to come from vSmart. It's going to come from vSmart. And everybody needs to have an active connection, OMP neighborship to vSmart. Everybody needs to have active neighborship to vSmart. Also, I forgot to tell you that this particular device, which is vSmart here, acts as a BGP route reflector, which means no two devices are going to have OMP neighborship to each other. If router A wants to talk to router B from control plane perspective, they needs to have OMP tunnel all the time, which is always there, right? So these devices are going to have tunnel to vSmart all the time. Which tunnel are we talking about? Which protocol are we talking about? Which neighborship? OMP neighborship. They will have OMP neighborship with vSmart. No two devices can communicate to each other. A cannot communicate to each other, right? Or cannot have a neighborship, OMP neighborship to each other. They cannot have OMP neighborship to each other. OMP neighborship has to happen to vSmart. vSmart acts like a route reflector to avoid any kind of looping mechanism. Guys, any question, any doubt, please type in the chat window. Okay, you can ask me a question. I've just tried unmuting. Guys, do not disturb if you do not turn on your mic, because other people are getting disturbed if you do not have a question. Only unmute yourself when you have a question. Deepika, yes, OMP runs inside DTLS. So take it, DTLS is by default there. All communication, because DTLS is underlay. DTLS is your prime level security. So every single thing is going to happen under DTLS. Yeah, I said tunnel by mistake. That was neighborship. DTLS neighborship, guys.
So, I mean, so there has to be a OMP neighborship with vSmart between every VHS, and there is a permanent DTLS tunnel between every VH to a vSmart, correct? Two different things.
Not two different things. One thing we have already discussed in the
Underlay and The overlay, correct?
When we were
That's what-
talking about the base thing, right? We already discussed that DTLS permanent is between vEdge to vSmart all the time, will never break, and vEdge to this thing, what do you call it? vEdge to vManage all the time, and vSmart to vSmart all the time, vSmart to vSmart. Because you can have multiple vSmarts in the company. Guys, anybody has done ACI, right? It's all similar. You do not have neighborship to each other to avoid any kind of loop mechanism. You basically have to need a route reflector kind of authority. So TLOC generally and OMP are difficult to understand topic, but I have tried explaining every single possible thing. See, all attributes, right? Because there is only attribute, nothing else. Once we do practical, things will become more clear. But from theoretical perspective, I've explained what are the attributes, and you can easily understand what are those, because those are basically plain English. So I'm done for today, guys. Any type of question, any kind of doubt, anything else you want to discuss?
Sir, actually, what is the significance of vManage over here?
Vmanage is a device on which you are going to do every single configuration, because configuration cannot be done anywhere else. All the configuration has to happen or will happen over Vmanage.
Is it going to be a physical device, or or a application kind of thing that can be hosted on a server and we manage it from there?
Okay, so what I'll do is I'll just show you. I'll take you to this particular Vmanage physical this thing. Okay, just give me a second. I'll take you to RDP access of our Vmanage server. It's a virtual device, and it comes in virtual form itself. As of now, no physical device is available for this. So it comes as a VM and a virtual device, essentially. Okay, so this is your Vmanage. I hope you guys can see that. So this is our Vmanage, and in this you have what we were talking about, which is basically was scheduled for tomorrow. You will be able to see your controllers, your vEdge, your everything. Now, all the configuration that you are going to do, although you can do a lot of stuff on CLI as well, you can go to vSmart and do configuration directly on vSmart. Every single possible configuration can be done directly on the vSmart physically. Okay. But as I said, that configurations are created mostly in Vmanage. If you want to create your vSmart related configuration, you can create it here. If you want to create your any device related configuration, you can create it here. Tomorrow is the install day. I will show you how to install the whole setup, and it's a little tedious process, but I want to do it from scratch so that you can see it. It will take probably 1 hour type of time. But if you do it with your hands, you see it clearly, it will be basically easy for you to replicate it and also to understand the concept. So this is a device. Now you cannot go to vSmart because there is no GUI for vSmart or vBond as such. There is only CLI access there, but you do not have any access available for vSmart or vBond. Wasn't just type it in the Google. Okay, see guys, from my classes, if you have checked my previous video, do not ask me a port ever. Okay, practically speaking, there is absolutely no possibility anybody can remember these ports. But if I type in Google, you will get it in 1 second, less than 1 second. Is it important to know what is the port number of something? When you can search in Google in a couple of seconds, what significance does it have that you remember the concept, you understand the concept clearly? There are going to be 3,700 more protocols, and it will not be possible for anybody to remember all those ports. So focus on concept. See, as of now, in none of the interviews ever that I've seen anybody asking for a port number from anybody. Okay, so focus on the core stuff. How, Deepika says, how are the V edges able to route to a TLOC as is logical and sysIP is non-routable? Okay, so that's a homework for you, Deepika. Guys, don't bring me to CCNA level, okay? Nothing irritates me more when we have to go to CCNA level and we have to talk at this, which port do you remember? And there is a memory test that goes on. Deepika, that is a task for you. Just read a little bit more, and it will be very easy to understand how is that system IP is being sent from one location to another, because I've just explained you, TLOC has all that information, right? It's a routing protocol. OMP is a routing protocol which has TLOC inside it, right? And because OMP is routing everything, TLOC information is routed from one location to another one. It's as simple. Guys, any question, any logical question, any other kind of doubt or anything else? Ron, any kind of question? SD class, yes. So SD access class, I'm planning to do it. Let me see, what's the time here? It's 6 a.m. Right now in India time. What's the time? 3:30. So put it like 9 a.m. is what I'm looking at. So 6:30 India time. Starting next Saturday, 6:30 India time. No, 9 a.m. US time, EST. Where is this server? This server is located in New York, actually. Yeah, it's actually located in New York. So V edges will not route. vSmart will only route as RR OMP carries your. Yeah, it's basically here in New York. Okay. So SD-WAN reference document, I will provide you. SD-WAN very good slides and PPTs I will provide you. Tomorrow after the class, I will share a Google Drive from where you can download all the images. Okay, I'll provide you where you can download all the images, whether it's GNS or you want VMware images, I have it. Also, I'll provide you documentation, the guide and everything else.
Hey, Vikas, this is Glenn. Just want to confirm, next Saturday, seems like 3 hours after your SD-WAN class, there's going to be an SD access class. Is that correct? Roughly.
I'm just saying that. Now I'm just asking you guys if that's fine with you and Ron and everybody else, or I can do it in the morning. I mean, before my class, I can do this class.
Oh, because I would prefer it that way. Basically morning, just before the class.
Yeah, so this class for me starts at 2:30 a.m. in my morning time on a weekend. So Yeah, so I'm up at 2:30 a.m. for this class right now. So anything earlier than that, I mean, I'll be sleeping in the class. So
Okay,
I would,
so
yeah, I know the guys in India probably want it earlier. Um, I'm okay with, after this class, like this class right now is 4 o'clock in the morning my time. So,
do you want
so
me
I
to
don't
hold
mind.
it for a couple of weeks? Also, I can hold it for a couple of weeks because I'm actually I booked this class only for our batches, internal batches, not for external students. So once everybody is comfortable on some time, then I can do it, after a couple of weeks also. That's fine.
Yeah, I'm in no rush to learn everything together because personally. So if we can do SD-WAN first and then do SD access potentially in the same time as this class over here, I'm okay with that. But
Okay, sounds good. Yeah. So I'm going to cancel it for next 4 weeks and then we'll decide, but let's do SD-WAN in a real good way and then we decide over the next topic. Okay, so feedback time, guys. How was it? Any feedback that you have?
yeah, I think I like the class because I think you were going at the right pace for me. So I'm learning I'm learning a little bit more about SD-WAN today. I mean, I did not have a good understanding of T-locks, but I think he explained that good to me today. So I appreciate it.
Okay, excellent. You guys have taken 6 classes, right? I was told that you have already done 6 classes.
Not me. This is Glenn. I only did 2 classes because
Okay.
those 2 classes were at this time, and then the other 4 classes were at different times that could not work for me because I had to go to work.
Okay, superb. So what else, guys? Ron, any suggestion where I can improve myself? My friend, are you sleeping? Guys, anybody else?
It's good because really.
Okay, excellent. So,
One thing, because are you going to upload the today's video in the Google Drive and you're going
I'm
to
going to
share
put
the
it on
link?
YouTube. I'm going to put it on YouTube because it's day 1. It's a demo class. And yeah, so I'm going to put it on YouTube. You can check it there. But rest of the classes, I will give you in an exclusive Google Drive or Dropbox. Each class, I'll share the Dropbox folder. And that's a place where I'm tomorrow going to share with you all the images, the software that you need, with the procedure, how do you install, get the license from Cisco website without any kind of credentials or, other things. So all that is basically going to be in a single folder. I'll share it with you.
Okay.
Yeah, and because how are you communicating in case there is a chance that you might cancel a class and stuff? Is there a WhatsApp group or is there email? How are you going to contact us outside the class times?
Yeah, that's a good idea. So because there are 80 people in this batch, I see what I'm going to do is I'll just create a Telegram group. And if you want to create it, that's also fine. So that I'm just doing it in a minute. And I'll type the group ID, SD-WAN. Okay, and one sec, I'm just going to share here so that everybody can join it. Exit.